Here we have a quarter of a circle, and inside of that circle we have a square ABCD, and we are asked to find the length CG. First of all, notice that the radius of this circle is 5. It's 3 plus 2. So OF and OG will be 5. The next thing we're going to do, we're going to take the point B and point C, and we're going to draw two segments, BH, which is horizontal segment, and CK, which is a vertical segment. Next thing, notice that the blue triangle AHB, blue triangle AOD, and the blue triangle DCK are congruent to each other by two angles on the side. The side we're talking about is the side of the square, and two angles are an angle of 90 degrees, they're all right triangles, and the second angle, this orange angle here, angle A, angle B, and angle D. For completeness, I'll show how to prove that this orange angle A equals to this orange angle B. First of all, notice that HAO is 180 degrees. 90 degrees out of this 180 is taken by the square, and the other 90 degrees is shared between this orange angle A and this angle HAB. On the other hand, if you look at the triangle HBA, sum of all angles should be 180 degrees. 90 degrees is taken by angle H, and now this angle A, HAB, and this orange angle HBA together should give us 90 degrees as well. Now if you look at these two equations, subtract one from another and rearrange the terms, we get what we were looking for, and that's the angle, this one, OAD, is equal to angle HBA right here. In a similar way, you can show that this angle A and this angle D are congruent. And since these three triangles are congruent, corresponding sides should be congruent. Side AO, which is 3, should be the same as side BH, and side DK. They're all 3. The next thing we're going to do, we're going to draw a segment OB, and that is a radius. It equals to 5. And now look at the triangle OHB. It's a right triangle. One side is 5, another side is 3. So the third side, the third leg, should be 4 by Pythagorean theorem. This is what's called an Egyptian triangle, with the sides 3, 4, and 5. But if OH is 4 and OA is 3, it means that AH, this piece, should be 1. Also notice that AF is 2. AH is 1, and that means that HF also should be 1. And now let's go back to our blue congruent triangles. Again, triangles are congruent, corresponding sides should be congruent. It means that if this side is 1 AH, it means that OD should be 1, and CK should be 1 as well. Now let's look what we have here on OG. OG is 5, it's a radius. It consists of 1, 3, and what's left here, GK, also should be 1. And the last thing is to look at the right triangle CGK. This is the triangle where both legs are 1, and that means that hypotenuse by Pythagorean theorem should be square root of 2, and that's our final answer.